Hi everyone, I'm Aria, an electrical tutor working with Roy. Today I would like to start this audio review questions series to go together with the audiobook based on the EWRB Electrician teaching guidelines. Please listen to the audiobook first, then use this audio review to test your understanding. Let's get started. Hi everyone, I'm Aria. Let's start our topic review. Before we begin, I just want to mention one thing. These review questions may contain mistakes. If you notice any mistakes, please point them out in the comments. I will double check them. If anything is corrected or updated, I will add the fixed questions in the video description below this video. So, when you listen to this audiobook, please check the description first. Thank you. Now, let's start. Topic 18: Basic Electronics and Semiconductor Devices. Listen carefully, choose an option, wait for the countdown, and then check the explanation. Review question 1. Which statement best describes what a diode does? Option A. It allows current to flow in one direction and blocks the reverse direction. Option B. It increases voltage in both directions. Option C. It stores electrical charge like a capacitor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A diode is a one-way valve for current. In normal forward bias it conducts, and in reverse bias it blocks. That is why diodes are used in rectifiers and power supplies to turn AC into DC. Review question 2. Where are diodes most commonly used in practical circuits? Option A. As rectifiers and power supplies. Option B. As mechanical switches. Option C. As heating elements. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Rectifiers need a one-way current path. Diodes provide that one-way action so AC can be converted into a pulsed DC that can then be filtered and regulated. Review question 3. Which device is best described as a diode with a gate control that latches on? Option A. SCR. Option B. Thermistor. Option C. Diode. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. An SCR is a controlled rectifier. A small gate trigger turns it on, and it generally stays on until the current falls below its holding current. That makes it useful for controlled rectifiers and soft start circuits. Review question 4. An SCR will turn on when? Option A. The gate receives a trigger signal. Option B. The device gets hotter. Option C. The reverse voltage increases. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The gate trigger is the control input. Without a gate trigger, an SCR blocks like a diode in reverse and forward, until triggered, so it can control when conduction begins in each AC cycle. Review question 5. A transistor is most commonly used as? Option A. A switch or an amplifier. Option B. A one-way valve only. Option C. A voltage reference that conducts backwards. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. In switch mode, a small control signal drives the transistor fully on or fully off. In amplifier mode, a small input signal controls a larger output signal. That is why transistors are used widely in control boards and power supplies. Review question 6. In a common emitter amplifier, a small base signal mainly controls. Option A. A larger signal at the collector. Option B. The resistance of a heater. Option C. The turns ratio of a transformer. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. In a common emitter arrangement, changes at the base cause larger changes in collector current and collector voltage across the load. That is the basic idea of amplification. Review question 7. A triac is mainly used because it can. Option A. Conduct in both directions on AC when triggered. Option B, only conduct in one direction like a diode. Option C, store charge to smooth DC. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A triac is designed for AC control. Once triggered, it can conduct during both halves of the AC cycle, which makes it ideal for lamp dimmers and fan or heater controllers. Review question 8. A diac is best described as: Option A. A small trigger device used to fire a triac at a set voltage. Option B. A cooling device for transistors. Option C. A device that steps down current to 5A. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A diac helps create a repeatable triggering point. When its breakover voltage is reached, it conducts and provides a sharp trigger pulse to the triac gate for consistent phase control. Review question 9. Which statement about thermistors is correct? Option A. NTC drops resistance as temperature rises. PTC rises resistance as temperature rises. Option B. NTC rises resistance as temperature rises. PTC drops resistance as temperature rises. Option C. Both NTC and PTC always stay the same resistance. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Thermistors are temperature-sensitive resistors. NTC types reduce resistance when heated, often used for sensing and inrush limiting, while PTC types increase resistance when heated, often used for protection and self-limiting behavior. Review question 10. A Zener diode is mainly used for: Option A. Voltage regulation or reference by conducting in reverse at a set voltage. Option B. Increasing current in a CT secondary. Option C. Operating as a mechanical isolator. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A Zener diode is designed to operate safely in reverse breakdown at a specified voltage. That controlled breakdown lets it clamp or regulate voltage and provide a stable reference. Review question 11. Why are semiconductor devices described as temperature sensitive? Option A. Too much heat can damage their internal junctions and shorten life. Option B. Heat has no effect on them. Option C. Heat only affects copper cables, not electronics. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Semiconductors rely on delicate junctions. Excess temperature can cause parameter drift, thermal runaway in some cases, and permanent damage. Heat control is a key part of reliability. Review question 12. Which method is most suitable for removing heat from power semiconductors? Option A. Heat sinks, thermal paste, and ventilation or fans. Option B. Increasing insulation resistance test voltage. Option C. Leaving the device in a sealed box with no airflow. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Heat sinks increase surface area, thermal paste improves heat transfer to the sink, and ventilation or forced air removes heat from the enclosure. Together they keep junction temperature within safe limits. Review question 13. Why can insulation resistance, IR, testing damage semiconductor devices? Option A. IR testers apply very high DC voltages, often 500 to 1000 V, that can punch through electronic components. Option B. IR testers measure temperature only. Option C. IR testers use low voltage that is always safe for electronics. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Most electronic components are not designed for high test voltages. If left connected, the IR test voltage can exceed their breakdown ratings and destroy junctions or insulation within the device. Review question 14. Before IR testing a circuit containing electronics, you should: Option A. Isolate or disconnect electronic parts before the test. Option B. Increase the test voltage to get a better reading. Option C. Bypass all fuses permanently. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The safe approach is to remove sensitive components from the test path. That protects the devices and also avoids false readings caused by semiconductor conduction paths. Review question 15. Which is a common cause of transient voltages in power circuits? Option A. Switching inductive loads and motors. Option B. A steady resistive heater operating normally. Option C. A fully charged battery sitting disconnected. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Inductors resist change in current. When current is interrupted, they can generate sharp voltage spikes. Motor switching and contactor operation are classic causes of transients. Review question 16. Lightning and supply disturbances are best described as producing. Option A. Short, sharp voltage spikes that stress semiconductors. Option B. Perfectly steady DC. Option C. No electrical effect on installations. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. These events create fast overvoltage pulses. Even if they are brief, the peak value can exceed device ratings and cause breakdown or progressive damage. Review question 17. Which measure helps minimize transient damage to semiconductor devices? Option A. Surge protection such as moves or surge arresters, plus good earthing and wiring layout. Option B. Using longer, looping wiring to increase inductance. Option C. Removing all protective devices. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Moves and arresters clamp spikes, snubber circuits control dV/dt and ringing, and good earthing and short, neat wiring reduce induced voltages and improve the surge current path. Review question 18. What does PRV mean for a semiconductor diode? Option A. The maximum reverse voltage it can safely block. Option B. The maximum forward current it can carry for any time. Option C. The maximum temperature of a cable insulation. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Peak inverse voltage is a reverse blocking limit. If the circuit produces a higher reverse voltage than the device PIV, the diode can go into breakdown and fail. Review question 19. If the reverse voltage exceeds a diode's PIV rating, the most likely outcome is Option A. Breakdown and possible device failure. Option B. Improved efficiency. Option C. Lower temperature in the junction. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Exceeding PIV pushes the junction beyond its design limits. This can cause immediate damage or weaken the device so it fails later under normal use. Review question 20. Why must a semiconductor device's PIV rating be higher than the circuit reverse voltage? Option A. Because the circuit can produce reverse voltage peaks depending on rectifier design and supply conditions. Option B. Because forward voltage is always larger than reverse voltage. Option C. Because PIV only matters for resistors. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Rectifier circuits create reverse voltage across non-conducting devices. Those reverse peaks can be higher than you expect, especially with transformer arrangements and transient events, so the device rating must safely exceed the circuit conditions. Review question 21. On many datasheets, PIV is often listed as Option A. VRRM. Option B. kVA. Option C. Zs. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. VRM means maximum repetitive reverse voltage. It is essentially the datasheet way of stating the PIV requirement for repeated operation. Review question 22. A single diode half-wave rectifier produces an output that Option A uses only one half of the AC cycle, giving a series of pulses. Option B uses both halves equally, giving very smooth DC. Option C produces no DC at all. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The diode conducts during one half cycle and blocks the other. So the output is pulsed DC with large gaps, which means more ripple and porous smoothing and less heavy filtering is used. Review question 23. What is the main advantage of full wave rectification compared with half wave? Option A. It uses both halves of the AC cycle, giving more pulses and smoother DC. Option B. It blocks both halves of the AC cycle. Option C. It always needs only one diode. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Full wave rectification doubles the ripple frequency, more pulses per second, which makes filtering easier and reduces ripple for the same filter size. Review question 24. A single-phase full-wave rectifier can be made using Option A. A center-tapped transformer with 2 diodes, or a 4-diode bridge. Option B. 1 diode only. Option C. A CT with its secondary left open circuit. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Both methods produce full-wave output. The center-tap method uses 2 diodes and a center-tapped secondary, while the bridge uses 4 diodes and does not require a center-tap. Review question 25. In a controlled rectifier using a single SCR, changing the firing angle mainly changes. Option A. How much of the AC waveform is converted into DC output? Option B. The transformer turns ratio. Option C. The PIV rating of the diode. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. If the SCR is triggered earlier in the half cycle, it conducts for longer and the average output rises. If triggered later, it conducts for a shorter time and the average output drops. Review question 26. Earlier firing of an SCR in a controlled rectifier gives Option A. More output. Option B. Less output. Option C. No change at all. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Triggering earlier means conduction starts closer to the zero crossing and continues for more of the half cycle, so more energy is delivered to the load. Review question 27. A triac controls AC power mainly by Option A. Firing at a chosen point in each half cycle to control the delivered power. Option B. Changing the supply frequency. Option C. Converting AC into DC using a bridge. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Phase angle control changes the portion of each half cycle that reaches the load. This is exactly how dimmers and many-speed controllers reduce power without changing the supply frequency. Review question 28. Controlled full-wave rectification on a single-phase supply typically uses Option A. SCRs firing at selected angles on both halves of the AC cycle. Option B. Only resistors and capacitors with no switching devices. Option C. A thermistor only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Using SCRs instead of plain diodes allows you to control conduction timing on each half cycle. That provides adjustable DC while still using full-wave rectification. Review question 29. Three-phase half-wave rectification uses Option A. 3 diodes. Option B. 6 diodes. Option C. 1 diode. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. In a three-phase half-wave rectifier, each phase uses 1 diode to conduct during its positive period relative to the return path. That gives 3 pulses per cycle. Review question 30. Three-phase full-wave rectification uses Option A. 6 diodes. Option B. 3 diodes. Option C. 2 diodes only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A three-phase bridge rectifier uses 6 diodes so that the most positive phase feeds the DC positive and the most negative phase returns to DC negative, producing 6 pulses per cycle. Review question 31. Which output is generally the smoothest before filtering? Option A, three-phase full-wave rectified output. Option B, single-phase half-wave rectified output. Option C, a single diode with no load. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. More pulses per cycle means less ripple between peaks. Three-phase full-wave gives 6 pulses per cycle, so the ripple is much smaller compared with single-phase rectifiers. Review question 32. Which statement best explains why more pulses equals less ripple? Option A. The time between peaks is shorter, so the output voltage does not fall as far between peaks. Option B. The diodes create extra resistance to stop ripple. Option C. Ripple only depends on cable size. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Ripple is the drop between peaks when the supply is not conducting. If peaks arrive more often, there is less time for the voltage to drop, so the output is smoother. Review question 33. Why are filters used on rectifier outputs? Option A, because rectifier DC still contains ripple that needs smoothing. Option B, because filters increase mains frequency. Option C, because filters are required to make a diode conduct. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Rectifiers produce pulsed DC, not perfectly steady DC. Filters reduce the ripple so the load sees a more stable DC voltage. Review question 34. Which component smooths DC output by storing charge? Option A, capacitor. Option B, DAC. Option C, SCR. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A capacitor charges near the peak and then discharges into the load between peaks, holding the voltage up. That fill-in action reduces ripple. Review question 35. In filtering, a choke is used mainly to: Option A, resist sudden changes in current and reduce ripple. Option B, trigger a triac at a set voltage. Option C, conduct backwards at a set voltage. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A choke is an inductor. It opposes changes in current, so it smooths current flow and reduces ripple, especially in power supply filters. Review question 36. In a filter network, resistors are often used to: Option A, shape and discharge the filter network and help control time constants. Option B, increase PIV rating. Option C, replace the need for any rectifier device. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Resistors can limit surge currents, form RC time constants, and provide a discharge path so capacitors do not remain charged after power is removed, improving safety and stability. Review question 37. Which combination is most accurate for filtering the output of rectifier circuits? Option A, capacitors, chokes, and resistors. Option B, only a switchboard and fuses. Option C, only thermistors and ZNs. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A practical DC filter often uses capacitors for voltage smoothing, chokes for current smoothing, and resistors for damping, discharge, and shaping. Together they reduce ripple and clean the DC. Review question 38. When comparing uncontrolled rectifiers, which is the roughest DC output? Option A, single-phase half-wave rectifier. Option B, single-phase full-wave rectifier. Option C, three-phase full-wave rectifier. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Half-wave gives 1 pulse per cycle, so there are long gaps between peaks. That creates the largest ripple and the least smooth output. Review question 39. Which statement best matches the role of electronics in modern electrical equipment? Option A. Many modern systems contain semiconductor devices, so understanding their limits helps safe work and fault finding. Option B. Electronics are only found in batteries. Option C. Electronics never interact with power circuits. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Modern drives, lighting, controls, chargers, and protection equipment all rely on semiconductors. Knowing about heat, transients, and testing risks helps prevent damage and improves troubleshooting. Review question 40. What is the safest key rule when working with insulation resistance testing near electronic components? Option A. Disconnect or isolate sensitive electronic parts before applying the high test voltage. Option B. Leave everything connected to save time. Option C. Increase the test voltage to make sure it fails if it is weak. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. IR testers can apply hundreds of volts. Many components cannot withstand that, so isolating electronics protects them from breakdown and avoids costly damage during testing. That finishes the Topic 18 review. Listen again, choose an option, wait for the countdown, and check your understanding.